In this video, we're going to be making copper 2 chloride. It's typically a dihydrate, copper 2 chloride plus 2 waters, and when it's all dried up, it looks kind of something like that. Interestingly, copper 2 chloride does occur in nature, but it's extremely rare. It's found usually in copper mines as the mineral aerocalcite. The anhydrous form is also found in nature. It's also rare, and it's known as nantokite. That's a tough one. Nantokite. Copper 2 chloride can also be made directly by combining copper metal with chlorine gas at pretty high temperatures, 600 to 900 degrees Celsius or 1112 to 1652 degrees Fahrenheit. Commercially, this is done by putting copper metal into hydrochloric acid and then bubbling chlorine gas through that mixture. Also commercially, copper 2 chloride is used in dyes, print ink, fungicides, and wood preservatives. I'll be using it in a future video to make sulfuric acid. Materials we need are copper metal. I'm going to start with 100 grams, so it is quite a lot. 31% hydrochloric acid, I'll start with 300 milliliters, and 30% hydrogen peroxide, 150 milliliters. The reason I'm using the hydrogen peroxide is similar to reasons I've used it before to dissolve nickel. Copper metal will not dissolve in hydrochloric acid alone because it's a non-oxidative acid. Oxidative acids are things like nitric acid. So it requires an additional oxidizer. The reason we're not using nitric acid here is we're trying to make copper chloride, so we need the hydrochloric acid. So the additional oxidizer is the hydrogen peroxide. It converts the copper metal into copper plus 2 ions, and those ions are then combined with the 2 chlorine negative ions to form copper 2 chloride. When you add hydrogen peroxide to this, especially if it's heated at all, which I will be doing, it breaks down into water and into oxygen gas, and we will see some of those bubbles. The overall reaction is copper metal plus 2 hydrochloric acids plus hydrogen peroxide gives us our copper 2 chloride and some water. In our methods, I'll be putting the copper metal at the bottom of a 1-liter beaker, adding the hydrochloric acid. I will be heating it somewhere around 40 to 60 degrees Celsius, and then slowly adding the hydrogen peroxide until it's done. Hopefully by then all of this will be dissolved and we'll have just one big solution of copper chloride. The bubbles that are formed, as I mentioned, are bubbles of oxygen when we pour in the hydrogen peroxide, and those can be excessive if this is really warm. They can bubble up and over, so you do have to be careful about that and just gently heat this. When all of the copper is dissolved, we'll cool it down and then chill it to approximately 5 degrees Celsius, during which time the copper 2 chloride crystals should start to crystallize out of the solution. We'll then filter the copper 2 chloride crystals, probably wash them with either a little acetone or ethanol, and then definitely air dry them. I don't want to overheat them and produce the anhydrous form. And that's it. We're at the end. So let's go to the beginning and make our copper 2 chloride dihydrate. Before we make our copper 2 chloride with copper metal, I wanted to show you 2 very easy ways to make copper chloride if you have these things laying around. The first one is with copper carbonate. I'm using 0.8 grams, 1.5 milliliters of hydrochloric acid. This is stoichiometrically close, but don't hold me to the fire. We should end up with around 0.87 grams of copper 2 chloride, but of course that will be dissolved in water. I'm going to take my 0.8 grams here of copper chloride and add the 1.5 milliliters of 31% hydrochloric acid. This will bubble, of course, because there's a lot of carbon dioxide that will be released. Okay, there's your copper 2 chloride solution. All you need now is to cool it, maybe dehydrate a bit, depends, but there it is. The second one here is copper oxide, starting with the same amount, 0.8 grams, adding this time 2.2 milliliters of 31% hydrochloric acid, which will give us 1.35 grams of copper chloride. Again, it will be dissolved in water. Now adding the 2.2 milliliters of hydrochloric acid. Now this is DIY. It might not be 100% pure, and I've done this before. Sometimes it does bubble because of some impurities, but it's taking a little longer for the copper oxide to dissolve, but you do have copper chloride solution there. Okay, let's now move on to making it with metal. To start making our copper 2 chloride from copper metal, we need copper metal. So that's what I'm doing right here. I'm taking this copper tubing and cutting it at 1-inch marks right here. Each one of these weighs about 6 grams here. And I could just put in a whole piece of tubing, but the extra surface area we'll gain by cutting them into smaller pieces will help them dissolve when it's time. I'll need approximately 17 of these in order to get the 100 grams we need, so I'll be back when I'm done with this. Getting these things right on the money is not easy, but here's 100 grams of copper metal pre-weighed. First thing I'm going to do is add the 100 grams of copper here to this 1-liter beaker. I did put a magnetic stir in there. I'm not sure how much that's going to be effective or not, but I figured put it in first before we start anything. Next simple step, adding the hydrochloric acid. Again, this is 31%. Copper, of course, will not dissolve in this well at all. It would literally take weeks at a pretty high temperature for that to happen. I'm going to heat the solution to approximately 40 degrees Celsius and then slowly add the hydrogen peroxide. It's taken a half hour with gentle heating to get this to 40 degrees Celsius. You can see some small bubbles on the copper, so at this temperature the hydrochloric acid will work on it in small amounts, but we really need the hydrogen peroxide to make this go forward. I have been using the magnetic stir, and I'll turn it on briefly here. It's not really working, but it is bouncing around, just helping the solution to get mixed about. So that's about all it's probably going to be worth until it is almost all dissolved. I'm not talking about the copper here. So let's add our hydrogen peroxide. One of the reasons I used a 1 liter beaker is because adding hydrogen peroxide will sometimes bubble quite a bit, especially when the solution is heated like this. So let's go ahead and start. I'm going to just add little amounts at a time. Okay, I'm adding just a little bit more here, and then we'll watch it for a bit. It's calmed down a lot. Obviously, it's still fuming quite a bit, so you need a fume hood to do this for sure. I'll periodically be adding the hydrogen peroxide. I'll be back when more of the copper is dissolved. A little closer view as I add the hydrogen peroxide. This will be the last addition of the 150 milliliters of hydrogen peroxide. The copper is almost completely dissolved here. You can just see tiny specks kind of swirling on the bottom there. Almost done. All of the copper is dissolved. I did end up adding another 60 milliliters of hydrogen peroxide after I said I was done, but it did the trick, and everything's dissolved. It was being heated, of course, and so we lost some water. Right now, this is supposed to be sort of a greenish color, but it's not. It's kind of a brownish green color, and I noticed when I put like a flashlight on the other side here, you can't see through this stuff at all. So it's pretty dense. Seems kind of concentrated, so I'm going to take a little bit out and we'll take a peek at what it looks like. I have a piece of filter paper right here and a small plastic pipette, so I'm just going to draw up a tiny bit here. Look at that. Yeah. I mean, you can see a slight hint of green there. Let's put some on here. Gosh, I think I invented motor oil. Ha! Well, that's obviously not green. That's way more brown than green. So I really believe this is definitely too concentrated, and I think I know what ended up happening now that I had a minute to think about it before I'm talking right now. We added hydrochloric acid and hydrogen peroxide, of course, but I did have to add extra hydrogen peroxide to get all of that copper to dissolve. And I think what happened was I was heating it, maybe a little bit too much, and hydrogen peroxide is broken down by heat much easier than hydrochloric acid. And I think that's what was happening. It was breaking down, so I had to add more to get all the copper dissolved. Now it's cooled down now, but I think in the interim we lost a lot of hydrogen peroxide, which means we have probably an excess of hydrochloric acid in there, and that's why this is so concentrated, because with the excess chlorine atoms it starts to form other copper complexes, one of them which is polymeric chlorocuprates. Now there's probably some copper 2 chloride in there, I'm sure of it. There might be a little copper 1 chloride in there, but I think these complexes are really what's causing this to turn this brownish color. One of the polymeric chlorocuprates is this right here. It's tetrachlorocuprate, and you can see it's got 1 copper surrounded by 4 chlorine atoms right here, and 2 plus minus 4 gives you the -2 charge right here. What ends up happening then is that you have another copper atom here that then combine to these 2 chlorine atoms and continue on the complex with 2 more chlorines here. Again, this is happening because it's too concentrated and there's too many chlorine atoms in there, and once they combine and continue to combine, it forms a polymer, and of course that's what a polymeric tetrachloride is, and that's the problem. So I have an idea here. What I'm going to do is divide what I have here into 1/3 and 2/3. 2/3 I'm going to just continue on to get the copper 2 chloride out, which I think I know how to do. With the 1/3 though, because I do believe there's copper 1 chloride in here also, I'm going to try to get copper 1 chloride out of the 1/3. I didn't plan on this, but since it's like this now, let's go ahead and try this moving forward. There's approximately 480 milliliters in the beaker, and 1/3 of that turns out to be about 160. So I marked this, I don't know if you can see it, at about 160 milliliters on this side here. And boy, the most basic of things, just dividing this up into 1/3 and 2/3, but here we go. Okay, doesn't have to be exact, I just wanted to have some decision. Gosh, this does look like motor oil, I really have to say. Okay, The next step is kind of crazy because both of these need to be diluted with water, but it's how I dilute them that will determine what happens next and how I'm going to get copper 2 chloride out of this and copper 1 chloride out of that. Now that we've divided the copper chloride solution, which is a mix of multiple things I already talked about, into 320 milliliters and 160 milliliters, I said both of them needed to be diluted with water, and it depends how we do it. And we're going to do that right now. Both need to be diluted because we need to drop the chlorine concentration that's in there. I chose this larger volume on this side because of how I'm going to dilute it with water to primarily get copper 2 chloride, which is what this experiment was all about. The copper 1 chloride is great, but it's not really what I was trying to do in the beginning. I'll just make the best of it. So I plan on diluting this slowly with water, and that will break up the polychlorine cuprate molecules without dropping the chlorine levels too quickly, because we're going to do it slowly. And I plan on doing that times 2, meaning I'm going to take the same volume of water, 320 milliliters, and add it to the 320 milliliters of solution we already have. Then we're going to evaporate it slowly, and this will allow the chlorine molecules also to evaporate slowly with the water, bringing the overall concentration of copper and chlorine to equilibrium, and that will in turn form copper 2 chloride. So if we go over this on the side here, so I'm going to double the volume by adding water. We have 640 milliliters, and then I'm going to drop it by 2/3, multiply that by 2/3, and we get approximately 250 milliliters in the end. And that's what I'm going to put in the freezer then, because we've been evaporating it, so it's warm, to try to bring out the copper 2 chloride crystals. I put start here because if this doesn't work, we'll just evaporate a little more water until we get the crystals to come out of solution. With the remaining solution of 160 milliliters, we're going to do just the opposite that we did here. Here, we're going to dilute it quickly by literally dumping in a bunch of distilled water very quickly. And what this does is drop the chlorine concentration so quickly that copper 2 chloride can't form. There's just enough chlorine left to form copper 1 chlorine, and so that's what we'll get. And this is water insoluble, so it falls to the bottom as a white powder, and then you can clean it simply because it's water insoluble by rinsing it with water repeatedly. If this didn't make total sense right now, I think it will as I actually do it, and you can see it happen, so let's go do it. This is simply an addition funnel I have here over the 320 milliliters of solution, and I'm going to add the 320 milliliters of water right now. Gosh, so difficult. I'm going to be stirring this, of course, so I'm going to turn on the magnetic stir here, and then just start a very slow drip rate. Doesn't have to be terribly slow, but just slow enough that we don't overdo what I'm trying to prevent, and that is putting too much water in too quickly. There we go. It'll take time, but patience is key here. Taken about an hour to add almost all of it. There's a tiny bit left in there. At this point, it doesn't matter if I just let it all go because that's already been diluted really well on the bottom, so I'm going to do that. And we're done. Next, we need to now dehydrate that solution. So I'm going to take everything apart and we'll start heating it. Now that everything is nice and simple, I'm going to start heating it, and I'm going to start around 50 degrees Celsius. Again, this has to go slow, and I'll kind of monkey with the temperature depending on what I see happen. Okay, I just drew this out of here, and I wanted to show you before I forgot that after adding all that distilled water, this did turn into this light green solution, which is how it should have looked from the beginning, to be perfectly honest. So it's probably going to darken a little bit as it continues to dehydrate. Well, after 10 hours of heating, we are at 400 milliliters. And again, because of the gentle heat, it is taking some time to get this down. But looking at this now, I think I'm going to try to crystallize this at maybe 250, 275, maybe even 300 milliliters rather than the 200 and a little bit there that I mentioned earlier. Just a gut feeling. It's almost time to turn this off here, the heat, and I just want to check the temperature one last time here. 61.6 degrees Celsius. Okay, the whole time it's been between 55 and 65 degrees Celsius. It's been slow, but that's exactly where we wanted the temperature. It's now down to just over 300 milliliters, but because it forms a cone in the center there, because of the stirring, I'm going to turn this off to see where it's actually at. Just above 300 milliliters. Well, the solution is pretty warm. We saw 61 degrees plus Celsius. So at this point, I'm going to turn off the heat, and it's going to, of course, evaporate until it cools down. And I think that will put it between 250 and 300, and that'll be just great. I'm going to try to crystallize it then. Well, my gut feeling was wrong. I should have gone with the numbers. You know why it's back on here? I didn't want to bore you with videos of something that didn't happen, i.e. the crystallization of copper 2 chloride. So I'm going to go down to the 210 milliliters I originally figured, and we'll go from there. I was checking this every 20 minutes, and I just came back, and it's right at, like, I'd say that's 210 milliliters, maybe 212. It's just a guess. But then I looked on the inside, and we have the copper 2 chloride crystallizing right there, kind of the magic number. And I'm pretty sure this is saturated enough I can just let it cool down. So I'm going to just do that, and when it's fully crystallized, I'll be back. I'm pretty sure it's crystallized as far as it's going to get. Those little marks there, I had to pull out the magnetic stir before it got to be solid. So I haven't poked into here yet. So there's still some liquid in there. Okay, no problem. Next step here, filter this stuff. Finally, we're here where we can actually filter this stuff. It took a bit to get here. I want to make one quick comment, and that is, breaking this up again a little bit here. You can see that this is definitely green. It's not that, I don't know, call it motor oil color. And so the effort of putting a lot of water in here and then dehydrating it definitely was important, because we finally have copper 2 chloride pretty much alone in here. Probably 99% of this is copper 2 chloride. So in spite of all that extra work, it was definitely worth it. Turn on the vacuum filter here. One of these days I've got to get a larger Buchner funnel, but I'll have to do this maybe in more than one portion. And an appropriately colored spoon. Ha! Well, that's just over half of it. So I'll complete this whole process and then I'll be back. Well, the dripping has slowed down a lot, but what's also happened is that the volume on the top is greater, and I think at this point I can get all of it in there. Okay, that's it. This is all liquid in here. Both the liquid in here and down there, I'm going to also boil down, not boil, but dehydrate it and see if I can't get any more out of there. But honestly, I'll probably do that after this whole video is over, because I'm ready to get this thing done. It's been running about 1.5 hours now, and it's pretty much stopped dripping. So I do want to clean it with some ethanol. I mentioned ethanol or acetone, and this is about 96-97% ethanol, and it was in a freezer that was 15 degrees Celsius, below zero, so it's really cold, and you still want to use it sparingly. Okay, that's plenty. I'm going to let that draw through, and then we'll dry it. Okay, that's dried out pretty well. I'm going to turn this off, scoop it out, and air dry it. This should dry pretty quickly, and I will come back and weigh it, but I don't think the weight will mean much as far as the stoichiometry goes, because we took part of it, a third of it, for the copper 1 chloride demonstration. Our copper 2 chloride is completely dried and ready to weigh. I just want to comment on the color. This is the right color of pure copper 2 chloride. You will see it in darker forms sometimes when it's made. If you have excess hydrochloric acid and or excess water in here, it'll be a darker green. So you want this light blue color. If you order it from a chemical lab, this will be the color you're going to get. Okay, let's weigh our copper 2 chloride dihydrate. $64.78 grams. Okay, that's a decent amount. I'm not sure how much the total will end up when I'm done dehydrating the other solutions, but it's a good start, and I'm very happy with the end result, especially the purity of this copper 2 chloride. Here's the 160 milliliters of the original solution that we separated earlier, and as I stated, I do believe there to be some copper 1 chloride in there, but we're going to produce it in larger amounts by dropping the chlorine levels in this so quickly that it really favors only copper 1 production, and I'll do that by loading a bunch of distilled water into that. There's about 200 milliliters of distilled water in here, and there's 160 in here, of course. So I'm going to add at least, I don't know, 120, 130. We'll see where we're at. And we'll let it sit for just a second. I'm going to go ahead and add another 100 or 120. As you can see, it's kind of, there's a little bit of guesswork here, but the idea is to drop it as fast as you can. So I let this sit here and nothing happened. And I kind of knew it wouldn't, to be perfectly honest, because it was still too dark, but I ran out of room on the top, so I couldn't pour any more water in. So I removed a little bit because I actually spilled it when I moved it last time. So I'm going to pour maybe 100 milliliters in this large beaker here. And now let's really drop those chlorine levels quickly. Now that's it. That's it. This is not 2 minutes since I poured all the water in here. And we can see when we finally correctly drop the chlorine levels fast enough, all of the white fine copper 1 chloride that's in here. It's even already starting to collect on the bottom. And you can see it separating from the top there. So eventually it will all end up at the bottom, and I'll be back then. Most of the copper 1 chloride has fallen to the bottom. There's still some in there crystallized. You can see the crystals. So I'll wait till it's completely done. But because this is insoluble in water, I'll dump out the top layer and then pour some distilled water in here and dump that out, and maybe do that twice and then save it underwater. So I just wanted to show you the final product here, which is this copper 1 chloride covered in water, which I'll keep it. Don't forget the small amount, and it, you know, it's not that small, but it came from a diluted solution and then it was diluted again. So there's quite a bit left that I could do this to, and I think, I don't know exactly the stoichiometry of it, but I would end up with a pretty decent amount of copper 1 chloride. And again, I probably will do that on my own off camera, but I just wanted to show you the end result.